We are at our final presentation for this evening, so we're going to hear from Allie. She's going to give an update to the work that she began last fall with Dr. Otto. And then once Allie's complete, I'm going to have a few quick announcements. So if you could just hang around for just a couple more minutes as soon as Allie's done. I want to make sure our graduating seniors, if you will, I think seniors is kind of termed loosely, because I know you guys have finished senior year of college, but our graduating supply chain students, I have a quick survey I need you to fill out. And then for our students taking this course in summer and fall, I have a few announcements for them as well. So we'll hear from Allie, and then we'll talk briefly, and then we'll be good to go. But again, thank you everyone for hanging in there. And I really appreciate everyone's participation this evening. All right, go ahead, Allie.
Great. I'll turn my camera on, because I showered today in the pandemic, so I feel like that should be celebrated. So let's get started. My capstone started in the fall, and it concluded this year, and I just want to take a minute to thank Dr. Otto for helping me out over this past year. It was a lot of meetings, phone calls, emails, so I really appreciate his help. So my capstone is titled Job Transitions, a New Model for Career Changers. You can go ahead, next slide. Table of contents, yeah, you can skip that. Everybody knows what it looks like. So changing careers can be a daunting task. I've changed careers quite a few times since graduating college, and it can be difficult to determine if your experiences can be applied to certain jobs within a brand new field. So the question is, how can you get from where you are to where you want to go, and how can I provide methodology to help navigate that path? Next slide. So the goal of my capstone was to research and implement a new model for analyzing job transitions. And that model would be based on US government occupational skills data, with the potential to provide unique and interesting ways to hop between occupations, while at the same time providing a wider, more integrated view of the occupational terrain. Next slide. So I used quite a few articles and resources while I was doing the capstone. The one that I referenced the most was the ONET online database, and ONET stands for the Occupational Information Network. It is a free online resource that contains data regarding the perceived importance level of 35 different skills for over 900 occupations. It is sponsored by the U.S. Department of Labor, Employment and Training Administration. So ONET has what they call data descriptors, and those can be used by job seekers, HR professionals, military veterans, college students. And those data descriptors are categories of occupational information that provide more than just a simple job description. I also read previous studies that have been conducted into why and how people change careers, just in order to understand some of the current tools that are available, as well as some of the psychology behind it. And I found that today's career changers are using a combination of formal education as well as informal on-the-job training. Go to the next slide. So my capstone approach is to use occupational skills and their importance to create a graph database, determine the shortest number of hops to attain a desired occupation, and then finding the optimal constraints to prune that graph network. I had to operate under a few assumptions, those being that the data was accurate, that skills are a key job requirement, and that job skills are acquired via on-the-job training, and then finally that all possible variables completely account for their impact on job transition. Go to the next slide. So in order to obtain shortest path, I had to convert the raw data into a graph network where occupational nodes are nodes, and the distance between the nodes is determined by the skills differential. So that means that when finding that distance, the Euclidean distance of node M skills must be less than the node N skills, because we only want to move to a job where you need to acquire additional skills to continue towards the end goal occupation. Move to the next. So obviously with over 900 occupations, 35 skill levels, pruning is going to be required. That's about 935,000 possible connections. So of the possible constraints listed here, I focused on the distance between M and N is going to be less than a designated max distance, salary preferences, and then overall absolute value of skills differentials. So in order to further prune the network and make the data more manageable, I actually grouped the specific skills back into their broader data descriptors as dictated by ONET. And those are resource management skills, basic skills, complex problem solving skills, social skills, system skills, and technical skills. So I added up all of the negative skill values between two occupations, and that became the overall absolute value for each particular skills category. So negative skill values mean that the job you're trying to go to requires more skill than what you have in your current position. And then finally, we would take that node network and use shortest path algorithm to find the most efficient pathway. Next slide. So what does that whole pruning process look like? So up at the top, you have the constraints applied, and those are in red. Those are the edges and the nodes. And then at the bottom, you have the actual pruned network, and you've removed any of that, extraneous data that you don't necessarily need is not applied to these jobs. So in order to get to this lovely pruned network, I ran a few scenarios with the actual data. You can go to the next slide. So constraint test number one was 0 to limited constraints applied. The only constraint applied was that the distance between the two jobs was less than 11. And it is important to point out at this point that all of the analysis that you're about to see, the absolute value of the skills differentials was actually used as the edge weights instead of the Euclidean distance. However, the Euclidean distance was used as a constraint in every single one of the tests. As you can see in that output on the left, the graph network is not really a viable option just due to the volume of the data. And it's also extremely limited in terms of a real world application. You have multiple industries represented, and that could be years and years of formal education, potential PhDs. And when it comes down to it, somebody's not necessarily going to take a $50,000 to $100,000 pay cut to go to a new job in a completely new industry. It may happen, but it's very rare. And so this one is a bit limited in the application. You can go to the next one. So constraint test number two, I applied multiple constraints. Those were pay increase of at least $1,000, a skills delta greater than 50, and a distance of less than 30. And you can actually apply the shortest path algorithm because you have multi-directional nodes. So if, for example, you look in the highlighted section down at the bottom, we wanted to find the shortest path from node 338, which is circled. And node 338 represents the occupation of supervisors of retail sales workers. And you wanted to go from 338 to 317, which is also circled, and that represents financial managers. You would need to use the mathematical software to get the shortest hops. So you would start at 338. You would move to node 333, which represents supervisors of non-retail sales workers. And then from there, you would move to node 11, which represents advertising and promotions managers. And then you could finally move to that end node of 317. And as you can also see with this test, you have what I'm referring to as mini node networks that have been created. And these standalone node networks violate at least one constraint. And that's something I'll go into in the next few slides here. So you can change slides, please. Finally, constraint test number three. So I took all of the test number two constraints. However, I tweaked them just a little bit. So this particular test, all of the occupations are within one occupational industry. In this case, it was manufacturing industry. And I also used a range of the skills delta. I used values between 50 and 100. As you can see, shortest path really wouldn't be needed because you can visually track the progression of the nodes and all the nodes are unilateral. However, it does give you the clearest and cleanest visual representation of everything that's been tested so far. You can go to the next. So my overall analysis of the data is that the applied constraints significantly impact the effectiveness of a node network. Even with constraints, there are often still too many nodes to graph. We saw that the network is easiest to understand when using a range of values for the absolute differentials of the overall skills. However, the smaller the range of values, the less node options. Additionally, specific skills play a significant role in the ability to move from one node to the next. And it is important to understand and have access to the skill values for each occupation or industry. And understanding that significance means it would be necessary to apply weights. And assigning weights to skills or skill groups could then be another constraint in the future. And finally, the greater the difference between two skills, the more education or training is required to bridge that gap. And those gaps are represented as those mini networks that we saw a few slides ago. The only way to determine which training or educational nodes we should use requires an additional comparison of skills. And I'm going to briefly touch upon this concept of adding these non-occupational nodes because I believe this can be the next step for this research. You can go to the next slide, please. So looking specifically at the constraint test number 3, the manufacturing industry. As you can see, we have nodes unconnected from the greater network. If you look on the left-hand side where I've highlighted a couple of nodes, so we're going to look at getting from node 492, which I apologize, it's the manufacturing industry. All of these occupations have very long names. I've tried to condense them where possible. So if we're going to go from 492, which represents a lathe and turning machine tool setter, and we want to get to node 64 at the bottom, which represents automotive engineering technician. Due to the constraints, you're able to go from 492 to 415, which represents polishing and buffing machine tool setters, but you cannot get to node 64. And so this is where it's important to understand the specific skills necessary for each occupation. Next slide, please. So using a pivot chart, you can get a visual representation of the skill scores for occupations. So the skill scores for all 3 of these manufacturing jobs are highest in basic skills and second highest in technical skills. So quickly comparing these occupations, there are opportunities for significant improvement in certain basic skills, such as science and reading comprehension, but even resource management skills, including management of material resources and social skills like persuasion and negotiation. So if you were to assign weights to these skill sets, you can get a clearer picture of where to go next. So let's say basic skills in this instance holds a weight of 6, social holds a weight of 3, and resource management has a weight of 1. So from there, we could modify the network as follows. Please go to the next slide. So the nodes and edges in yellow represent these non-occupational additions. So using the skills comparison chart, you can determine which direction to go next and what's needed to get there. So the yellow nodes can represent training or even formal education in some instances in any of the skill areas identified by the ONET data, assuming they have the necessary weight to get you from the main network into these mini networks. Next slide, please. So where do we go from here? I do recommend using a software with greater processing power necessary to run all 900 plus nodes. I found that there are limitations when using a single laptop and one software program to analyze this much data. It definitely could eliminate the need for additional graphs or charts. With time and resources, I believe that the perfect level of constraints could be achieved in order to optimize the node network. Also, assigning weights to the skills would be the ideal way to gauge its necessity to a particular occupation, and then that would also help prune this network. And I think that's something that would need to be done cross-functionally, partner with HR experts or even government agencies. And that was an option I was going to explore at my company. I was going to lean on some HR personnel. Obviously, with the pandemic hitting, their priorities are elsewhere, so that wasn't something that was able to come through. But I think that that's something that's necessary if you were to explore the option of assigning weights to these skill scores. And finally, I think it's important to determine how best to fill the gaps between certain occupational nodes. So this will most likely be different for each network, both within one industry and to make hops across different industries. Obviously, multi-industry hops will most certainly need education and training nodes added to the network. Next slide, please. So in conclusion, creation of a node network is helpful when occupations are grouped into their larger ONET categories. I found the greatest success using multiple constraints. I used 3. Anything greater than 2, probably between 2 and 5 would be ideal. But even with applying multiple constraints, I limited the maximum value of the Euclidean distance while maximizing the skills differential. Excuse me. So additionally, weighted skills results would certainly help to create a more intuitive matrix. And again, HR professionals would most likely be the best people to lean on in order to provide insight into what would be an appropriate weight. And while this project was a great introduction to the data and analysis, more research is needed in order to create a truly comprehensive tool for career changers. So one that can draw data from multiple sources and then run simultaneous analysis. You can go to the next slide. That's my reference slide. So that's the conclusion of my presentation. I'll open it up for questions if there are any.
Okay. Questions for Allie? Any questions for Allie? All right then.